Hello everyone, welcome back to my channel. Let's learn mathematics by understanding concepts of mathematics. Today we are going to see exercise 1.2 from chapter number system, which is included in a CBSE syllabus, that is mean in NCERT textbook. So first question from exercise 1.2 is state whether the following statements are true or false. Justify your answers. That is mean we need to give a reason why the given statement is true or false. So first statement is every irrational number is a real number. So what do you think about the statement? Is it true or false? Let's understand by the figure. When we think about the number system, there are different kinds of numbers present in a number system, and all these numbers are included under one heading, that is real numbers. First type of number is natural numbers. Natural number starts from 1 and goes infinitely many. So natural numbers are 1, 2, 3 and so on. When we add 0 in a natural numbers, then all numbers together with a 0 considered as a whole numbers. That is mean whole numbers starts from 0 and it goes onwards infinitely many. When we add 0, then positive natural numbers and negative natural numbers, then that numbers considered as integers, and all these numbers are included in a rational numbers. Rational numbers are the numbers which we can write in the form of p by q. Q is not equal to 0 and p and q are any integers. So first of all comes natural numbers, then whole numbers, then integers, and then rational numbers. With all these numbers, one type of number is also included, that is called as irrational numbers. Irrational numbers are the numbers which we cannot write in the form of p by q. So for example, which is root 2, root 5, then pi, all these numbers are irrational numbers. All rational numbers on all irrational numbers together called as a real numbers, or combination of these two numbers, that is mean rational numbers and irrational numbers combinedly called as a real number. So every number is a real number. Natural number is a real number, every whole number is a real number, every integer is a real number, every rational number is a real number, every irrational number is also a real number. So this statement is true because every irrational number is a real number. We understood by from the figure. Statement is a true. How we can write the reason? See, now we can write, we know that real numbers are combination of rational numbers and irrational numbers. In short, we can write real numbers is equals to rational plus irrational numbers. Every irrational number is a real number. Second statement is every point on the number line is of the form root m, where m is a natural number. Then on number line we can draw here and 1, 2, 3, 4, -1, -2, -3. That is mean on number line we can show that all positive numbers 0 and all negative numbers also. But when we think about a root m form, that is mean any number which is a natural number and written under root form represent on a number line. For example, see, if suppose root 4, now root 4 is a natural number, it is written under root sign. So root 4 it will become as plus or minus 2, plus or minus 2. That we know that root of any perfect square number we can get positive as well as a negative root. If root 4 is there, then we can get roots as plus or minus 2. Plus 2 is also we can represent on the number line, minus 2 is also we can represent on the number line. One more example we will see, root 16. Now root 16, if we find the square root of 16, it will become as a plus or minus 4. Now 16, which is a natural number and it is form of root m. Square root of 16 will become plus or minus 4, and plus 4 also we can represent on the number line, minus 4 we can also represent on the number line. Means wherever m's value is a natural number and that is a perfect square, then positive as well as negative root we can represent on number line. But what about root 5? In case of root 5, 5 is a natural number, we written under root sign, that is root 5, it is same as a root m. But in case of such type of irrational numbers, we cannot get negative root. Root 5 we can represent on the number line, but negative square root of root 5 we cannot represent on the number line. That whole statement is a false in case of irrational numbers. Now what reason we have to write? We cannot represent negative roots of every number which is in the form root m. Now third statement is every real number is an irrational number. Real numbers is the combination of rational numbers as well as irrational number. That is mean every rational number is a real number, every irrational number is a real number, but every real number cannot be a rational number, or every real number cannot be a irrational number. So this statement is a false, because every real number is not a irrational number, it can be a rational also. So we can write answer as this statement is a false. How we can write the reason? Reason is, how we write? We know that real number is the combination of rational and irrational numbers. So we conclude that every irrational number is a real number, but every real number is not irrational number, it can be rational too. Now question number 2 is, are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Now first we will see the examples. Now suppose root 4, when we find root of a 4 or square root of 4, it will become as a 2, which is an integer and rational number. Root of a 25, it will be 5, which is also rational number. It is not necessary to square root of every positive integer will be a irrational number. In case of root 7, when we find square root of 7, it will be a irrational number, means root 7 is a irrational number. By observing above examples, we can write that square root of every positive integer will not an irrational number. It can be rational too. It can be rational 2. So today we saw question number 1 and question number 2 from exercise 1.2. That's all for today. Keep watching. Thank you.